So Rules Go kind of got started as the first major Starlark rule set. So I worked on this together with Ian Cottrell. We were both on the Go tools team. We worked down the hall from the Bazel team in New York, so we got to go bug them and ask questions. It was kind of nice. There was a lot of API churn in Bazel in kind of the pre 1.0 days. Like every version was just like kind of throwing the cards up into the air, and we were picking them up and trying to maintain compatibility. It's gotten a lot better since then. The documentation has also gotten a lot better. I think it's still very oriented toward being like a reference documentation. You have like a big list of definitions of things, but not as much on the tutorial and explanation side. And so I set out to write a series of blog posts that this course is based on. So I have a link to the first one here. And the idea was that we're going to, rather than take an existing rule set like Rules Go that has like a lot of complicated stuff, like it needs to interact with C++ and handle exotic platforms and so on, we're going to take like the simplified version. So the code that this course is based on is called Rules Go Simple, and I don't know if you've ever seen the English Simple Wikipedia. It's like Wikipedia, but it's a different language. It's still English, but it's like written, explained like I'm 5. So every page on there is just like, the 1,000 most common words in the English language. Like it's really easy to read. And so I wanted to create a rule set that was like that we can have a course based on. So this is not actually used in production, but it does build real Go code. It just like handles the simple cases, so you can kind of get an idea. Just the level of this course that I'm expecting, kind of beginner to maybe intermediate Bazel users. So I think probably everyone here has run Bazel commands. If you haven't opened a BZL file, that's okay. We're going to start pretty fresh here. I guess like maybe I can get a show of hands, like what or maybe just call it out. Like what are people interested in learning? Like what are you interested in getting out of this course? Anyone? Yeah.
Organization.
Organization, sure. Like rule set organization, like how to organize the repo. Anyone else? Yeah.
Understanding when to write a rule.
When to write a rule? Yes. Yeah. Like rules versus macros, generals.
Like conventions on how to write a rule that's like idiomatic and that plays well with other rules.
Sure. Idiomatic rules.
Yeah.
Is there a hand over here?
Yeah, I was going to say best practices. I think that goes hand in hand.
Best practices.
Providers, how to define, so you interop well into the future.
Yeah.
About what not to do.
What not to do. I guess I'm curious, like how much are people interested? So I have like more material than will actually fit in 2 hours. So I'm curious, how much are people interested in the like tool chain and repository rule and module extension side of things versus just like kind of the, binary library test run files type of thing? Which one?
Binary libraries.
Yeah. Okay. Everyone feel that way? Either one?
I've got the binary library thing down. It's the other stuff I'm interested in.
Yeah.
Do you have anything on validation actions?
Validation actions. Tell me more.
It's a little corner stuff.
I'm just now learning about this, and I don't have any material on it, so sorry.
I vaguely remember reading something about that. Yeah.
That's pretty cool. Okay. All right, let's go. So I have the kind of curriculum here. Each one of these is a different unit. I think we'll spend kind of a small amount of time on the concepts. For the first few, I'll generally do like a kind of a live coding exercise, so you can like stop me and ask questions, and you'll see like how we go through this. If we had like half a day, like I'd have you all out with your laptops. So like please do feel free to like go in later and check out the repo and do these exercises on your own. But so I'll go through like at least 2, 3, 4, maybe certainly 5. So we'll go through like binary library test. And then if we have time and if there's interest, then we can get onto the tool chains and module extensions later on. All right, so concepts. So everyone's seen a build file before, right? So we have our load statements, our rules, our targets. I'm going to try and be careful here to say the rule is the type of thing. So the rule is like the Go binary, and the target is an individual instance of a rule. I have been kind of sloppy, and I think the Bazel documentation has been a little sloppy about the distinction between like rules and targets. So a lot of times people will say like a rule is an instance and a rule class is the whole type of thing. I think that terminology is a little bit obsolete, so rules and targets is a little bit more clear. I'll try and stick to that. We have our attributes, so we'll be defining attributes later, different types. So we have label lists, we have strings. They can be in the same repo, other repos. You probably know about labels. Repo. So repo, kind of a workspace. It's a top-level directory, has build files, has either a workspace file or a module.bazel file, instantiated by repo rules. You know about packages, targets. We talked about labels. Actions. So an action is like a command that Bazel runs. And the purpose of the rule is to take like kind of a description of what you want to build and reduce it into a series of actions. So from a user perspective on Bazel, you don't really see actions that much. You might see like kind of the scrolling output, like it's, you know, CC, compile, go compile, whatever. But the actions are not super visible. Like the rules are the ones that are actually defining the actions. Macros are different than rules. So macro is just a regular function. It may instantiate several rules. It may declare several targets. We're not going to be talking about macros very much. There is somewhat new functionality in Bazel, which is symbolic macros. These give you a much more structured way beyond just like a regular function. I think in some future version of Bazel, they want to make these lazily evaluated so that they don't all get expanded. I'm not sure. I don't think we're there yet. And attribute. So this is like an argument to a rule. Okay, so why are we writing these? We're declaring actions. So we're building a big graph, essentially. And so each action is a node in this graph, and the edges between the graph are files. So the output file of one node can be the input of another. These are how things get joined. And the rules are basically making the user's life easy. So they can just say, this is a CC library, this is a Java binary. They don't have to think too much about what the actual dependency graph looks like. They can focus on a higher level of the dependencies between their targets rather than the dependencies between the actual files and actions. So rules oriented around like a logical goal rather than like the low-level actions. Rules can return providers, so they can communicate with other rules. So this is why you would why you would actually write a rule instead of a gen rule or instead of a macro. We'll get a bit into that a bit when we talk about libraries. But the providers, like this communication between rules, is really important. Lastly, like rules can use tool chains. So Mike in his course said tool chains are dependency injection. And the idea is that a rule doesn't have to know whether it's using GCC or Clang or whether it's for Linux or Mac OS or something. A rule just says like, I need a tool chain. It has this type, and it can get that injected, and then it can create actions based on that. So you can't do that with macros, at least. I think not easily. All right, let's get into actually writing some code. So if you want to check this out, it's on GitHub, rules go simple. Prerequisites, you will need, at least for the first several units, you will need a copy of Go to be installed in your path. So I'm going to jump into the code now. Ooh, nope. Hang on. All right. How legible is that? Is that visible in the back? Yeah, okay. Just a quick tour of the repo. So I'm going to start in our module.bazel file. I'm going to be the module elitist now, and we're not even going to have a workspace file. You know, it's future-proof course. So we declare our module name here. There are lots and lots of comments. I'm not going to read them all out. We have one dependency. This is Bazel Skylib. Skylib is, or I guess was, kind of the Starlark standard library. So there's a lot of stuff in Skylib that will help you write rules and test rules. I've learned that Skylib is actually going into like Google maintained mode, which means that they're not really accepting contributions anymore unless they directly support Google projects, which is kind of too bad to hear. But there's still a lot of useful stuff in here. There's another library previously was Aspect Bazel Lib. Now it's renamed to just Bazel Lib. So Bazel Lib is a module on the BCR you can get now. It has Skylib, but it has a lot of other additional stuff. So check that out too. We're going to keep it real simple and just use Skylib in this course, and we're actually barely even going to use that. I would recommend having a def.bazel file. And in terms of conventions, there are a few different places you can put this. Usually it will be like language name /def.bazel or language name /defs.bazel, either one. I just put it at the top level directory. The purpose of this file is it has all of your publicly defined symbols. So Starlark doesn't have any way to say like this is a private symbol, this is a public symbol. You can just load whatever. It's a little bit like Python in that respect. And so I'd recommend, yeah, question?
You can declare load visibility now.
Load visibility?
Yes.
Yeah, where would you declare that?
You can declare it in your BZL file to say what's allowed to load it.
Oh, I didn't know that.
Yeah, I have a vague recollection of something blowing up but not being private, and I was like, what?
That's new to me. Good to know. I've generally just had like a private directory. I think this one has an internal directory, so that hopefully should be warning enough that anything in there may change, and anything outside of that is you can rely on. Question?
Yeah, percent of private directory, Bill Fire, like that too. When people seem to be split on def.bazel versus one file per rule that people need to load. Could you talk about that?
I think, yeah, varying opinions on this. One file per rule means that you need to load fewer files. So there's less overhead in Bazel actually evaluating the Starlark code to load the file in the first place. I think that's advantageous if loading more files would trigger download of additional repositories. I'm not that worried about the time to evaluate Starlark code, especially the like top level files. I think those are very fast to evaluate. I mean, the rules themselves, if you're evaluating the rule function like, 100,000 times, like that matters. But just like the file level evaluation. So, I mean, personally, I like to keep it simple and just have one file with all the definitions. But I think there's kind of a trade-off there. I will say there's a rules template repository in the Bazel contrib GitHub organization. So if you want like a convention to follow, like an actual layout that like is standardized, like that's like kind of semi-standardized. And I forget which way they went with this. I kind of think it's one big file. But check that out too. I think that's actually like language /defs. So I'm not quite following that convention here. So yeah, we're just defining our Go binary, and it is loaded out of our internal rules file. I put, let's see, in the internal directory, I split actions and rules. And so the reason I did this will be apparent when we get to tool chains, if we get that far in 2 hours, which maybe we won't. But I like having separate functions to create the actual actions. And so there are two reasons for that. One, you can just like stick these onto tool chains and make them kind of methods of the tool chain object. That works really well. The other thing is if you want some composability between rules, you like for Go, we want to be able to compile from several different rules. So Go binary is going to need to compile stuff. Go library is going to need to compile stuff, and we want to share that code. So anticipating that, I've split this out into two different functions. There is, in this course, a Go standard lib rule, which I'm not going to talk about almost at all. I wanted to start from scratch and just like, kind of hello world. The fates did not allow me to do that. In Go 1.20, they stopped shipping a precompiled standard library, which means Bazel actually needs to build it before you can do anything else. And building the standard library is surprisingly hard within Bazel. Like the sandbox kind of messes with it a little bit. You have to like dereference symbolic links and copy things around and like copy things out of it. Like it's not interesting. I don't want this course to be like focused on Go really at all. It's just an example. And so I'm gonna hand wave that a little bit. Like we can talk about how that works a little bit later, but at least in the first part of the course, just it's magic. Just trust me. All right, and finally, we're going to actually implement our Go binary rule. So let's try this. So this repository has a bunch of branches. There are different versions that correspond with the different units. And so the exercise branches just have a bunch of the code removed. And so if you want to like work through the exercises and figure out how things work yourself, like type things out, check out the exercise branches and then compare them with the original to see how well it goes. So I'm on the V1 exercise branch. So how do we do this? So we have Go binary equals something. We're going to call the rule constructor. So this is just, it looks like a function. We need to give it an implementation, which is a regular function, which I'm going to put up here. And we need to say like what this rule takes in. So we're going to give it a list of attributes, which is a dictionary. And I think we're going to say sources. So this is an attr label list. And when you define a list of attributes, you can say like, okay, what type of files are these going to be? Are they going to be files? Are they going to be rules? Is it, what are the requirements here? We need to say, let's see, allow files. And I'm going to depend on that standard library. So the standard library attribute, I declare with an underscore. And that means it's an internal hidden attribute. You never actually say like I have a Go library and this is my standard library. Like it's underscore, it's secret, it's hidden. There's an internal thing. You have to set the default on this because the user has no way to actually set it themselves. And so this is a way for one rule to depend on a target implicitly defined somewhere else. So we have this internal standard lib. It's just like a single thing for the whole system. So for our implementation, we need to compile something, and then we need to link something. So first, we're going to say, we're going to create our main object. So we say context actions declare file. So this tells Bazel, I'm going to create an output file. We need to tell, like we're defining this part of our dependency graph. And so we're saying like, this is going to be an edge. And we're going to say like, here's the action that creates it. So the file's name is context label name, which is, if I say go binary hello, this is hello, plus .a, the extension. And then I'm going to call my go compile function. Let's hide this guy, split. This takes in sources and a bunch of other stuff. Oh, I should point out, every rule implementation takes in this context object. And this context object is essentially Bazel's API for rules. It has a huge list of methods that you can call. Actually, I'm going to pull up the documentation for that. Sorry. Ooh. Context. I just have this bookmarked. Sorry, that's super small. No, I have like a folder of Bazel bookmarks. So like if I want to look at attributes or globals or, yeah.
That's good, yeah.
That's very smart.
This has a ton of stuff. So you can look at actions. Like a lot of this is even broken into separate objects. So actions like declare file, declare directory. I guess if you want to do nothing, you can do that. Highly recommend bookmarking actions and a bunch of other pages. Question?
Can you talk a bit more about this Skylib shell? And like, is it if I wasn't using Skylib, like, from my understanding, like, could I call another shell command another way, or is this like the way to execute the shell command?
Where do you mean? Do I have that up?
This in actions, you're using Bazel Skylib shell.
Yes, this. I'm using it here for the shell.quote thing. And this is the go compile action. And I have to run like a complicated shell script, which I'm going to simplify later. But in order to run this, I'm going to inject some strings into the shell script, which may or may not contain spaces or quotes or whatever else. And so the one thing that I'm using out of Skylib is shell.quote in order to properly escape all of that stuff and be able to inject it into a shell script. So yeah, especially if you're doing anything shell related or anything Windows related, that's very handy. I would recommend like not doing anything with shell scripts if you can possibly avoid it. But we're starting out at the beginning, and like in order to avoid it, you need to build a binary that can like have all your code in it that like does the stuff. So well, we need to start with shell scripts. Like this is the bootstrapping step basically. So we're calling this with sources, context files.sources. Import path, we're going to call this main. Our standard library, context. Ooh, I forgot something important. I'll surprise you with that later when it fails. And our output is main. Okay, so we've probably compiled this. I don't know if it works yet. It certainly does not work, I'll guarantee that. Next, we're going to link it. So we have executable, another actions declare file. This one is just named after the rule. And we'll say go link, def go link. All right, so this one takes our main file that we just declared. Oh, we need our context. Our standard library again. And our output, which is the executable. And then one last step, we're going to return the default info provider. And so this tells Bazel what we actually built. So this contains the output files. It doesn't actually have to contain all the output files. So we're actually going to say files equals dep set, only the executable. So when you say Bazel build something, this is the list of files that it's going to print saying like, hey, I built this. And if you like interact with Bazel through like the build event protocol or anything like that, this will be apparent, like this will be in the default output group. And so if you have a script or something that depends on the output files, it'll get this. It doesn't have to contain like all the other intermediate files. So the main.a file that we built up above, that is inconsequential for the user. And so we're not going to include it here. But it is part of the dependency graph. So it still does get built. We'll go into providers a little bit more later. Okay, so we've called these functions. We haven't actually defined any actions yet. We have this big ugly command. It doesn't really matter what it does, but we need to like tell Bazel to actually run that command. So we're going to say context actions run shell. We give it a mnemonic, which is a very hard word to type for some reason. So mnemonic is kind of a keyword for the type of action. It's just like when you run Bazel build, you see these things printed. Like this is like kind of an identifier for the user so they know what's going on. We're going to give it a command, which is this big string. So we just called string.format on it, like it added our substitutions. I don't believe it takes any arguments. We are going to give it a list of input files. So that will be our standard lib plus our sources. And the outputs, we're expecting just the out file. And that also definitely won't work, but we'll be surprised by that in a minute. Okay, and we're going to do the same thing real quick for GoLink. So context actions run shell, mnemonic, commands, inputs. We actually only have two, so we just have our main and our standard library and our outputs. All right, let me make sure I didn't forget anything.
Where can I find that repo for this?
This is rules go simple, so github.com/jconrod/rules go simple, and you'll find this. All right, let's see what happens. So we have a bunch of failures. What happened? Okay, so I referred to the standard library with context.file. And ordinarily, when you declare a label attribute, you have to say, like, am I going to get some files here? Am I going to get one file here? Is it going to be executable? So if you say context.file, you're expecting exactly one file. And in fact, it's a directory, but only one. So we need to tell Bazel that. So in the rules and the rule declaration, we need to say allow, oh, not that one. Allow single file. And let's try again. Nope. Okay, so it's telling me the go command wasn't found. So this initial version, like, we're just depending on the go command that's installed on the user's system. Bazel wants to be hermetic. It wants to isolate the actions from the rest of your system. So that means that it's going to run with a very limited set of environment variables. Ideally, it's going to run in a sandbox that has like less visibility into at least the rest of your project and hopefully some of your system too. So we kind of need to cheat a little bit and be able to see the tools that are installed on the system. And so in order to do that, we're going to add this line to our action. So we called context actions run shell here. We're going to say use default shell environment. And I'm going to add that to both of the actions. So what this does is it's going to take some of the shell environment from the user's environment, wherever you invoke Bazel build. And in particular, what we need here is the path. So I have Go installed in some weird place, and it's not user bin or something. So it needs to be able to take stuff from my path and actually use that inside the action environment. This is, again, not hermetic, so don't do this. We'll see how to do it in a better way later. Like toolchains is the right way to do this. You want to download the toolchain, configure Bazel to use that. But for now, we're going to cheat. And it passed. So there's just like a hello world binary in there. There's like a shell test that verifies that it can actually be called and like produces the output. Question?
I should know this, but does the, like, if you run it and I run it, do we get different action IDs? Because of
Yes.
The, okay, then.
Wait,
Yeah, I should know this. I just want.
I don't know.
I mean, you should, at least conceptually. To be running this to go.
I don't know, actually.
So I saw you use .a as the library extension and Go extension for the binary. Like running on Windows, might use .obj and .exe. Is there a way to configure that, or is that?
For the executable on Windows, .exe would be correct. Go.
Configure that in the rule, I mean?
What?
Is there a way to configure that in the rule?
Yes. So you can say, where would we put that? I was talking about Mike about that. I was talking about this with Mike earlier. It is somewhat hard to tell what operating system you're on within a rule. And so what you can do, let's see, where am I?
For CC stuff, it's in the toolchain config.
There's some recent changes to Skylight from Fabian that do that.
So if you want to do it the old way, like kind of the hacky way that we've been doing since new features were introduced to make this more reasonable, you can go into context.configuration, which gives you this object. So this has some stuff like coverage enabled, test environment. So I've used host path separator because Windows is the weird one. Like it's / on Windows, it's / everywhere else. It's exe on Windows, it's nothing everywhere else. Like, I don't know. Okay, not great, but it works. Oh, you asked about .a. .a is,
Same question, same answer.
yeah, for Go, like .a is actually correct. It's an internal format. Like it is like the Unix archive format, but it's just used internally and it's always used on any operating system. All right, back to the slides for a little bit. Okay, so let's review. We talked about the repo structure. We talked about how we actually declared rules with the rule constructor. So this creates a callable object. It's not actually a function. So when you call a rule, it looks like a function call, but it's not literally a function. It just like registers a rule, and you give it strings. They turn into labels internally later. So I mean, it looks like a function, but it doesn't quite walk or quack like a function. The implementation, however, is a regular function. So this is called during analysis. I'll talk more about that in just a second. The context object, it gives us access to all the attributes. So you can access them through context.adder, just for the raw, like target, strings, whatever. You can say context.files to get a list of file. I did that for the sources. You can say context.file to get one file if it's a standard library. So a few different ways to access your inputs there. Context.actions we use to declare our output files and the actions that produce them. And finally, we returned the default info provider. I've been just talking about Starlark. I'm just assuming that people know what that is. It's kind of like Python. It's a limited subset of Python. It's like they started with Python and then they took a bunch of stuff out. So it doesn't have modules. It doesn't have classes, exceptions, generators, floats, async, whatever. The idea is it's simple. It's simple. It doesn't actually even allow recursion. It doesn't have while loops. You can loop, but it's only you're looping over a list and not over a generator or anything. I don't know whether it's Turing complete. I think a lot of things are accidentally Turing complete. It is supposed to not be Turing complete. It is supposed to run in a deterministic amount of time, like every Starlark program should halt. Why? Why not give us like a superpower? Like why not write all this in C++? Build is complicated, and if you were given a complicated tool, you will write complicated code. So I think the idea with this is that you have one job here. You're just supposed to create a graph. Like just part of a graph, you declare your output files, you declare your actions. And if you can do, if you have a lot of complexity in that, try and push it out into code that is not Starlark. Starlark is for like very simple minimal code. All of the complexity should be pushed out into a real programming language. So we're going to talk about that a little bit more in the efficient execution section. But like if you find that Starlark is like not powerful enough to do what you want, like think about how can I write this code in not Starlark. Build and module files, also written in Starlark, even more limited dialect of Starlark. So you can't have top-level if statements or loops in build files. You can have list comprehensions, which let you kind of templatize targets, but that's pretty much it. Very limited. One other thing that might not be obvious, if you load a .bzl file, a Starlark file, everything that is reachable from the global scope of that file is available, but it's frozen. So the Starlark runtime is actually going to go through all of that reachable data, all those apparently mutable lists and dictionaries and so on, and it sets a flag on those saying, like, this cannot be modified. So if you load a list out of a BZL file and you try and append something onto it, that will break. Like, that will give you an error. Which means that Starlark files can actually be loaded in parallel. So Bazel can like fan out through the graph, load them in parallel. And it also means that if you have a function that has, in Python, you have this problem where you have a list of parameters and you say like some parameter, the default value is a list. Like that list is set once when the function is defined. So if it ever gets modified, that modification is visible to every future call of that function. But that's not really a problem in Starlark because it gets frozen. Like you're guaranteed that that doesn't happen. The solution to that in Python is maybe using tuples, which are not modifiable. At least the tuple itself is not. Starlark doesn't have tuples, so don't do that. If you want to use Starlark, by the way, this is a general purpose language. Like it was invented for Bazel, but you can use it in other projects if you like. There's a Go implementation, there's a Rust implementation, and of course Bazel is written in Java, so I think there's a Starlark interpreter in there too. Phases. Bazel works in 3 phases. There's the loading phase and the analysis phase and the execution phase. And this is really important to understand as a rule author, not so much as a Bazel user. The purpose of the load phase is to build the target graph. So we're just in this phase, we're evaluating all the modules, like figuring out the module graph. We're reading all the build files that might be related to the build. And we're figuring out the dependencies between those targets. But we're not actually building the file action graph yet. So the file action graph happens in the analysis phase. So the analysis phase is when the rule implementation functions actually get called. So Bazel is going to like recursively call your implementation functions. This is after it has resolved all of those labels into targets, and it's figured out all the configuration stuff already. So this is when rules actually do something. The rules in this phase are very limited. So rules can't have any side effects. They're just basically pure functions in Starlark. They cannot do any I/O in particular. They can declare output files and the actions that produce them, but they can't actually read files. You can't like read files to figure out what the dependencies should be and then like figure that. No, you have to declare it ahead of time. They also can't run any commands directly. So like repository rules can do this, module extensions can do this. Regular Bazel rules cannot. So it is just a pure thing. And the purpose of this is so that like it can all be cached. So this all happens on the user's machine. The product, like the analysis phase, gets cached in memory. And whenever you run Bazel again in the same configuration, you can reuse that output. You may see like if you change a Bazel flag or something, it says like discarding analysis cache. That's what's happening there. So it's dropping everything in the rules output. And then the execution phase itself, this is when Bazel runs commands. So it has the full graph. It can tell like what it needs to do. So the commands have like everything. They have like actual arguments. They have inputs, outputs. There are a few different strategies for running commands. So you control this with Bazel's spawn strategy, test strategy flags. Kind of the default is the sandbox mode. I should say default on Linux and Mac OS, although they work differently. Windows doesn't really have a sandbox. So the idea is that each action is kind of isolated. You have to explicitly say what the inputs and outputs are, because what you really don't want is for an action to actually depend on other files that it hasn't declared, because if those files change, then the action will give you the wrong result when you load the cached version of it. So I used to work a lot with makefiles, like I think it's been 15 years now. And at the company I worked, we had to run with like make j equals 1, like one core, one job at a time. It took 4 hours to build the thing that we were building because we didn't have explicit dependencies. It was not safe to run with multi-core. And Bazel forces you to declare this and forces you to structure your build in a way that is parallelizable. And part of the purpose here, like beyond just the sandboxing that enforces this, is remote execution. So like Bazel originally, or Blaze originally used Forge, and like Forge was like the Bazel remote execution. So you can run like hundreds of jobs at a time. And so the company that I'm employed by provides this service. There are several others, but I mean, I think this is really the strength of Bazel, is that you can use a shared cluster, run your commands there, and get very fast builds. But that only works because everything is declared ahead of time. It only works because of this execution isolation. So that's really important. That's why things work a lot of the ways that they do with rules. Question?
So, something I've always wondered is that do all the actions inside a rule are executed even if they're not used as they're lazy?
They're lazy. So you can declare a bunch of actions. They will. When you say like Bazel build some target, Bazel is going to figure out, okay, so it's going to produce like whatever part of the graph, whatever subset of the graph is needed to understand everything that target depends on and what the output files of the target are. So we did default info earlier. So what files we're talking about in the target graph are just those default info files.
Whichever actions you, like specifically within that, whichever actions you need to produce that's the only thing that's going to run.
So it's essentially going to run like a depth first search through that part of the graph, like starting with those roots, and it will collect like all of the actions that are needed for those, and then like run whatever subset of those actions are needed if they're not already in the cache. Yep. Files and targets. We just kind of glossed over this, like maybe it's somewhat intuitive. When you say context actions declare file, that gives you a file object. You can refer to it with context.files, context.file for input files. You can get the path out of that. There's like a .path attribute. Bazel will only ever tell you the relative path from where the action runs. And the action is going to run in a directory that looks like it's the root directory of the repo. Not actually like Bazel is going to create like a directory somewhere else, but it's going to be kind of apparent. So you'll get relative paths. Bazel can't give you absolute paths because that would break isolation. The absolute path could be some temporary directory. It could be different on one machine from another, so remote execution would break. So you'll only ever get relative paths to make that hermeticity work. The target, you'll get this through context.adder. So we had like context standard lib, so we could get information about the target. This is mostly used to get provider information, so we'll see that in a bit. Right now. Okay, so libraries. I showed you Go binary earlier. You could have written this with a general. Like it was like two actions, like it could have just been a script, right? But the kind of the strength of rules starts showing up when you need to compose like many of these rules into a single thing. So what we need to do with libraries is when we have a binary, we don't want to say like all of the libraries that thing depends on recursively. But we do need to pass that whole list into the linker. So we need a way for like each library in the graph to kind of pass information like what it depends on and so on back up to the Go binary that like is the root of that subgraph. So in order to do that, we're going to have a provider, and a provider is just a named struct. It has some information about our target. We can put kind of whatever we want in there. And we're going to put a depth set in here. Depth set is a Bazel data structure. So Starlark doesn't have sets, but we do have depth set in Bazel. It does now?
Yeah, they added it in 9.
Oh man, I need to like keep up with the changelog.
It's in Bazel 8.
Yeah.
It's in Bazel 8?
Yeah.
Okay. So depth set, like still kind of the right tool for the job here. The purpose of depth set, let's see, I'm going to skip past the exercise. I'm going to come back to it in a minute. But the depth set is like a tree of lists with some kind of implicit deduplication. So the depth set has, what?
It's a tag. This time it's true.
Yes. That's right. It is actually a DAG. It's a joke from the last session for anyone who wasn't here. So a depth set has two parts. It has a direct part and a transitive part. So say we have a depth set of strings, like each one of these blocks here, like the direct part is up top, so this one has ABC, and then the transitive part is on bottom, so this depends on 2 other depth sets. They're immutable. You can't change anything. The contents also have to be immutable. I think Bazel verifies that when you create the depth set. So you can generally put providers in there. I think you're somewhat restricted on other things you can put in. If you actually want to iterate over one of these, you call the toList method on it. Try not to do this very often. Depth sets tend to grow very, very large. Like these are kind of introduced at Google to deal with binaries that have hundreds of thousands of dependencies. And so iterating over all of them, like you don't want to do it on every node. You only want to do it when you're linking at the end. So just be aware of like accidental O of n squared stuff. You can set the iteration order. So you can say like, I want pre-order, I want post-order. Maybe that doesn't matter, maybe it does. For C++ linking, there's a lot of idiosyncrasy there where it matters. And internally, when you're walking over this thing, it uses a hash set to make sure it doesn't return the same thing twice. And so implicitly, everything that you put in here has to be hashable. Back to the exercise. Let's actually go write some code. Yeah. I'm going to discard all my hard work from before. OK. So starting off in our def.bazel file, we have our Go library, and we have Go library info. So this is new. I put this in providers.bazel. So provider is, again, just the struct that it contains some information. I would suggest putting this as part of your public interface because it allows people to write rules that are compatible with your rules. So for example, if someone wants to write Go proto library, they can return a Go library info provider that is compatible. That means you should probably put some thought into what you put in here. Like it's kind of a hard thing to change later, so be careful and don't make incompatible changes. So we have 2 things in here. Let's unsplit this. So you actually can just say like provider, like you have to call the provider constructor, and this returns like another constructor. So it's like kind of a second order constructor. So you give this a list of fields and documentation for each field, and this can end up as part of like generated documentation. So we're going to put 2 things in here. One is info. This will be a struct. It has 2 bits of information. Critically, it is the archive file that we'll produce for each library. So this will be the compiled.a file. And we'll have a list of a depth set of dependencies. And the depth set is actually going to be of these info structs. So when we get to our link stage, this depth set is going to be like all the information that we need to link the binary from all our, we'll collect that from all our dependencies. All right, let us write our rule. So again, I started with nothing. At least I wrote myself a hint so I can remember. So we'll call our rule constructor implementation and adders. So we need our sources. This is a label list as before. We'll have our depths. This is new. This is also a label list, but we're not going to allow our dependencies to be precompiled files. So we're not going to take A files from before. So no allow files. We do want to say these have to be Go targets. So you can't have like a Java library or something here. And to do that, we say providers equals Go library info. So whatever we depend on has to return these providers. Question?
You loaded that, right?
Yes. Good question. Yes, you do have to load it. We're going to have an import path, so each library has to have its own name. This is just an adder string. We're going to say it's mandatory. And we got to have our standard library. Let's see, this is allow single file. Okay, I think that's everything we need.
For sources, would you also want to allow a single file?
Um,
In case you have a single file?
I don't think you can use allow single file with label list. You can only use it with label. So if you're depending on a list of things, you wouldn't be saying like, you would be saying like out of this entire list, there's one file. You wouldn't be saying like for each one of these targets, there has to be one file. This is part of the reason, by the way, you wouldn't access like your input files through context.adder, like through the target object. You want to access them through context.files, because context.files flattens all of the dependencies into a single list. So each dependency can be a collection of files. It could be like a file group or something, or it could be like an empty glob or something. Okay. So we need to declare our output file. So we're going to call that out. Context label name.a. We're going to call go compile. Actually, I have to set the import path this time. And let's see, import path. Standard library. Dependencies, okay. So what should we pass for our dependencies? This is going to take a list of those Go library info objects. Yeah. What? Oh, yes, yes. That would have blown up in my face. So for each of our... Oh, yeah, I messed that up too. No. That one is intentional. I was about to type that. So I have a list of targets, and I want a list of Go library info for each target. So I can say for each dep in context adder deps, I want to map that, and I'm going to use this subscript notation. So dep sub Go library info. So this looks like an array indexing thing. You're actually passing the Go library info symbol, the constructor in here. And this is what gives you back the provider. So it's symbolic. You get back the provider object, or you pass in the provider constructor rather than like a string that says it's this provider. Did you have a question?
Yeah, is the dep object in that context, is it a literal dictionary?
It's a target. So it's if you...
This is a Bazel sort of...
Yeah. Once again, going to my... Oh, I don't have this one bookmarked. I think it's in...
Built-in types.
Built-in?
Yeah.
Where is that? Oh, I see. Somewhere in here.
Yeah.
Target.
Here you go.
No, but my question was like, so we are overloading the syntax for the... Bazel is overloaded the syntax, so it's like a Bazel tag.
Exactly.
Ah, okay. So we couldn't write a struct or like something to replicate that ourselves.
Nope. No operator overloading. At least no user-controlled operator overloading in Starlark. Yep. Let's see. What is it? Yep.
Does it mean that a target, there could be target that return more than one what's called provider tag?
Yes. Yeah. Target can have a list of providers. I mean, if you have like Go proto library or something, you might have like your Go providers, or your proto providers. You probably, like almost every rule is going to need to return default info. So that is also a provider. It's one that's always in scope, but you can think of it still as a regular provider. And there are a few others too. So if you, like there's a concept of output groups where you can like ask for different things from the same rules with a -- output groups flag. So there's an output groups, I forget the exact name of it, but you set that up through a provider. Let's see, was I actually, no, okay. More code.
One more thing. like even though you mentioned like you need that provider, if the particular dependency you gain has other providers, you could in theory also access them. Like it doesn't filter everything else out of the target, or does it?
I think you have to say in the attribute which providers that you expect.
Yeah, but like I claim here in my attribute, I expect Go library, and then but if this is a bad practice, horrible, but like if within the rule I try to access, hey,
You can't, it's an error.
what? It's an error.
It's an error.
But I can access default info.
Default info is, well, it's default.
Default, well, you don't literally get default info. Like you get it, like if you get the files, then you get like context.files.
But what do you have? The run file. The run file is also somewhere.
Run files.
So, but it is everything else is.
There's some built-in ones.
Yeah.
Yeah.
Okay.
Yeah.
Okay.
Yeah, there are other ways to get the run files. All right. So we compiled, we still have, oh yeah. We have to create one of these things. So we're going to say this is Go library info. And what did we need to put in there? We're going to have our, okay. I guess I have to rename this because I'm going to say info equals something. So there's this built-in struct constructor. This is like a little bit like named tuple in Python. So you can just say like, it's essentially a dictionary, but it's different syntax. Like it's immutable once it's constructed. So we have to say this is import path equals something. And archive is the out file. And then we need deps. So again, this is a dep set of info structs. So this is not a dep set of Go library info providers. This is a dep set of these things. So again, we need to map this. So we're going to say dep Go library info dot info for each dep. Okay, that should do it. And we have to return that. You're right, that is supposed to be a dep set. So this is, we have to do our direct. That was the direct part. The transitive part is each dep set. All right, that was everything?
One is info, and the other one is deps.
I mean,
Could you not reuse the depths list from second line?
I could have. That would have saved me a very small amount of code. Yes, that is possible. Dep set.
Are these different types?
What?
Direct and transitive.
Why are they different types?
Yeah. Right? Like,
So-
they're going to be different types. Shouldn't the depths also be?
The deps are
The-
deep sets of the type of the right?
So the overall type of this is like dep set of info, and so this
So the transitive is not.
this is also, or this is a list of info. Transitive is a list of dep sets of info. We'll see if Bazel doesn't like it. I think this is right. And let's see. Let's see, was there anything else I was supposed to do? Okay. This is asking me to do the same thing for Go binary. Oh, I guess I was going to skip that, but I guess it's kind of important. This course is normally a little bit longer, so I'm kind of looking in places where I can shave off a little bit of time. This is the linking stage, so we need to like actually go over what all of these are, and we need to pass it to Go compile. So I think what I'm going to do in the interest of time is just switch to the solution. And we'll see how that works. so Go binary, we created our main archive as before, and we need to compile it. And so the compile step of the main archive is just like a library. We only need the direct dependencies. We don't need the transitive ones. We do need to pass in the Go library for each. So this is exactly like we did for Go library. The executable, on the other hand, let's see. Okay, so the executable, we pass in these providers. So let's see how that's used. So we create a depth set of everything. So the direct, and we get the transitive from each one. We kind of saw how that was constructed earlier. So this is similar. We're creating our scripts. We're doing our text substitution, which includes an import config file. So in Go, we need to tell the linker, here is a list of import strings, and here are the corresponding files, where to find them. It used to be there were these like -i and -l things like kind of like C++ where you can like directories. Go doesn't do that anymore. You actually have to write out a file that has that mapping. And so we need to produce that file. And we also need to do a bunch of complicated stuff to absolutize it, which we can't do in analysis. Remember, Bazel doesn't give us the absolute paths. So the bash stuff does that for now. We'll see how that's done in Go a little bit later. But this is the part where we actually call that toList method on the depth set. So this is where we get that full list of dependencies, and we generate like lines for this file, and then in the bash script we can process that. Questions so far?
What are the reasons why you would write a custom provider?
So
When do you need to do that?
I think you need to do this whenever you have one target that depends on internal information from another target. So in this case, like for libraries are a great example of this, because like our binary depends on a bunch of libraries, and those can depend on a bunch of libraries and so on. But the binary needs to know all of the libraries, like everywhere in the graph. We need to collect those into like one big list. But each library doesn't really have like in the build file, you don't say like the full transitive list. If you did, then you could just write a general or a macro or something. But because we need to communicate that information like kind of upstream through the graph, we need to do that with the provider. And that also means that we need to write a rule to do it.
Is there a standard set of providers that pretty much all compiled languages are using where, you know, you have this linker? It seems like it's kind of like shared functionality across multiple tool chains or languages. Is there like a defined rules? That's like info, that's a set of dependencies?
Not really that much.
So it's kind of like general structure, anything goes kind of deal.
There's default info, which just has like the files that each target produces. But beyond that, it's pretty much all language specific. And so like each language, like each rule set will define its own providers. And I mean, they are part of the public interface. So for example, like Go has some interoperability with C++. So you can, in some cases, like produce a Go object that can be linked into a C++ binary. You can link C++ libraries into Go binaries. And so there is some exchange of providers there. They have to know about each other. Like Go can return C++ providers or like consume C++ providers.
So that's done at the object level instead of the rule level, the provider level.
Yeah, it's at the rule level. Okay, I'm going to switch back to slides. Okay, we talked about depth sets already. Some debugging tips. Starlark doesn't have a lot of again, Starlark is a very simple programming language, so it doesn't have a lot of facilities that you might be used to. Like one of the examples, like you don't really have a debugger in Starlark where you can set like breakpoints and so on. You probably are going to end up with some printf debugging, And so there is a built-in print function, and you can just give it any string. And you can convert objects into strings and like properly format them. Question?
Fail too, right?
Fail, yeah. You can call fail to basically return an error. There's no structured error handling in Starlark, so there's no like try, except if you call fail, that is fatal. There's no way to recover from it.
Is there a pretty print?
Pretty print? No, you just get print. You just get strings. Yeah, this is going to show up as a debug line in the output. So it'll be a different color, but it's just going to be kind of an ugly string. And it's useful for debugging, but probably omit that from user visible stuff.
Equivalent of logging levels where you can say, like,
Nope, that's all you get.
There's like a progress message you can print, I think, or some actions that's useful sometimes. I'm thinking of
You're probably thinking of repository rules. So like the Starlark rules just declare what the actions are. Once the rule is done, like it doesn't run any more code. So when the actions are running, like the rules are already finished.
good mnemonics go a long. Good mnemonics go a long way as well.
Yes, yeah,
That's what we found.
yeah. Yep. Your question?
A tip with print runs when the function it's in is executed, and if Bazel doesn't need to rerun something, say it's done in the loading phase, and the result is cached, you won't see it again.
Right. So you might need to clean if you're expecting something that was cached.
Or you tweak the prefix and the print string.
Yes. Some sandboxing tips. So Bazel runs things in a sandbox. What this means depends on the operating system. So on macOS, for example, there's some macOS built-in sandboxing where you give it like a configuration file saying like what files it's allowed to access and so on. This is kind of weird. Not everything works inside the sandbox. And also, even if you're not using a sandbox, it'll like create symbolic links in places you don't quite expect. So I mentioned like problems with the, ran into that same problem with the cable. Yeah. Anyway, long story short, if you have a failure that you believe may be caused by sandboxing, you can try spawn strategy equals local, and that disables sandboxing. So if you have something that fails in the sandbox and passes outside, try this. Be careful if it this is not part of the action ID. So if it gets cached when it's running in like local strategy, it will still be cached when you turn the sandbox back on. So you can say like, oh, everything's fine now. It's green. Like my build is green. Like git commit, like whatever. And then someone else is going to be like, what the hell, man? Doesn't work. So be careful. One of the problems I ran into with like preparing for this was like symbolic links are different inside the sandbox. I don't know, like hard links. The macOS sandbox didn't let me use hard links for some reason. I don't really know why. I don't know. Sandbox debug. This is a useful one. Normally Bazel deletes the sandbox directory. It's just gone at the end of the build. So if you set this to true, it'll leave the sandbox directory behind. So you can go in there and poke around and see like, oh, some file should have been here. I needed to add that to inputs. That's probably like the most common type of error. Subcommands, if you want Bazel to like print everything that it's running, that's very useful to see like, oh, some argument was here that shouldn't have been so long. Testing. I took a simple approach for this. I put like a bunch of buildable targets in the test directory for this project and just like have some shell tests to verify that they actually can be built and like the executables can be run and so on. That's nice as long as you're verifying that things work. If you're like trying to verify failures, that's very difficult. So verifying failures generally means you need to run a Bazel command like inside a shell script and verify that it has some output you're expecting, like whether that's like a return code or some text or something. You can wrap scripts like that as Bazel tests, but you're running Bazel within Bazel, you generally need to like create some output directory so it doesn't like, you know, rebuild everything and like refetch everything every time you run the test. There is rules Bazel integration test that does this for you. That is mainly oriented toward testing multiple versions of Bazel. If you want to test, I think that also does not support like failure testing. So there's not really a standardized solution for it. Like Go has its own, Scala I think has its own. So sorry, good luck. Yeah, Skylib has some testing facilities. Bazellib has some testing facilities too. So this is more oriented toward like unit testing, Starlark functions. If you have complicated Starlark code, first of all, why did you do that? Second of all, you can test it this way. All right. I have 45 minutes left, so I think I'm going to be very brief about run files, and I would like to cover efficient execution. I think that's important stuff for everyone to know, and then we can kind of dip our toes into repository rules and module extensions. Okay, so data. Again, everything is isolated. We need to declare our inputs and outputs for every action. But we also need to say, like, oh, this action needs these files at runtime, and Bazel actually needs to build them. So they could be certificates, configuration files, that type of thing that you might not actually need during the build, but the binary needs them to run. And especially if you're running the binary as part of the build, like it's a tool or something, you want run files to collect all that. So we get a run files object. You can create it with context run files. It's actually quite a bit like a dep set. I don't know why it's not a dep set. Does anyone know in the back maybe? No? Okay, well it looks like a dep set, but it's not actually.
So it's like a goose instead of a duck.
Yes, yeah. I love the metaphor. You can combine them with run files merge. You attach them to your default info provider, just like the other things. Generally, if users need to specify these, you'll create a data attribute. There's nothing like magical about the word data. I think there was in the past, but now that functionality is deprecated. So data is basically a regular attribute. If you want to access these at runtime, it's complicated. No. Actually, I wanted to get to this slide. Fabian created this excellent talk. I think this was in New York in 2022, if I remember correctly. It was run files and where to find them. So this was a previous BazelCon talk. It talked all about how Bazel actually puts these on the file system. This talk, if you're writing a rule set and you need to create a run files library, this is an excellent resource. If you're just consuming run files, then please use one of the libraries that someone else has created and just like don't depend too much on the details, because it's a little bit different depending on whether you're Bazel running something, or if you're running something as an action, or if it's a test, or if it's on Windows. Like those are all like different dimensions, and it's all like you have to test like all of those. It's very complicated. So just use the library, and if you're writing a library, then I'm sorry. Question?
How should you package up an application with its run files?
How should you packaging? I think that depends a lot on the language. I think. No, that's a good question. Like if you're packaging the application, that means you're not running it with Bazel, though, right? I think then you don't use run files, maybe.
Package tar.
Package tar, yeah. So yeah, so there's rules PKG. It has some rules for creating tar files. I think it can also create zip files. It can create deb files, like for installing on Debian. There's a couple different rule sets for containers, for containerization. But I think in that case, if you're running outside of Bazel, then I wouldn't use a run files library for that. Like use some packaging rule to make sure that the files are in some predictable place and then access them like regular files.
Two paths, one with Bazel and one without.
I mean, it kind of depends on the use case. Like if you expect the code to run through Bazel run, then like use run files. If you expect it to be packaged and running somewhere else, then don't. Like.
You could set run files during yourself.
getting dangerously close to depending on the details.
Is it fair to say that Bazel Run was a shortcut for a culture that distributed tools initially via the source control system? Like instead of packaging a dev and then installing that on everybody's machine, they'd say, hey, just go to the tip of the tree and run our command with Bazel Run, basically.
I don't know that like services were ever like primarily using Bazel Run. I think if you were building like a
Convenience thing, right?
yeah, I don't think it was like the primary mode of distribution, but it's certainly useful if you have like a little web server, you want to Bazel Run it, or there's like iBazel that reruns Bazel Run if there are any change, like it watches the file system and so on. It's a convenience layer. I don't think it was meant to be like the primary way things are distributed.
So, in an executable target, if you're not depending on anything external or in anything that is not in either generated or is already in your repo, is it safe to just, within the binary, just go to the relative path relative to the workspace and just forget about raw files? It's like, is that advice? Instead of using a library for like resolving these things.
If you're outside of Bazel?
No.
Oh, within.
Using Bazel Run.
Bazel Run. Not on Windows.
Okay. But if it's not on Windows, it's fine. I have this impression that it's only when you start to deal with like external and like something stuff that's not in your workspace that run files become like.
I think for the limited case where you know the file is in the same repo,
Yeah.
you can use a relative path from the repo root. I think that will work in most cases.
That's my experience, but I always
Yeah.
wonder, am I messing up? So,
I mean, Windows is the hard part. So
there's no way. That's not in my life.
just to explain, like what Windows does, Windows file system is very slow at like lots of operations on small files. And so what they do there is instead of creating this whole run files tree, where it's like a directory tree of symbolic links and so on, symbolic links are also not allowed by default on Windows. Like you have to go into settings and turn that on. So on Windows, Bazel writes out a run file manifest, which is a file that contains a map from the paths to the actual paths. And so the run files library goes and reads that manifest and like does that dereferencing for you. And again, this is like another dimension. Like you can make the Bazel Windows do the regular run file symbolic link thing. It's slower, but it's more compatible. So enable run files as the flag. All right. Yeah. If you need to reference run files in build files, there are these new, the make variable expansion is the name of this, the documentation page that has this. So you used to say like $parentheses location or locations. I believe now the recommended way is exec path and root path, though I'll confess I don't actually know quite how that's different.
To actually pass path for a run files library is our location path.
Our location path. Okay.
You want to get the key you pass into the run files library. And use our location path to get that.
I'm
Which gets passed to the our location function.
Yeah, so if you don't know the path ahead of time and you need to get it from like, I just have the label, then you can pass that to our location paths and then use the run files library. So I have to look this up because this has gotten like, run files just like are beyond the complexity I can handle.
But try to avoid location.
Yeah, don't use location. All right, let us talk about efficient execution. So far, I've been using shell scripts in this course, and I've also been depending on the stuff that is installed on the system. And we're at least going to solve the first part of this, and we're going to take a step towards solving the second part. So what we would like to do is take all the complexity in our rules, which is actually like, our rules have wrapped bash, so that is like 2 layers of complexity. Bash is very non-hermetic, like you can have different tools with different meanings installed on the system or not installed on the system. If you're running in like a minimal Debian container or something, you may or may not have the patch command installed, stuff like that. So I would highly recommend getting outside of bash as quickly as possible. And that generally means that you need to build some other binary using rules, and then do like all of your other like complicated intelligence stuff through that binary. So what this does, I'll show you the code in a minute. I'm not going to live code this. We're going to have like a single Go tool binary. So this is like the bootstrap binary. It's still going to be built by shell script, but once we have that, the compile action and the link action are implemented by that binary. So we're going to pass it just like a little bit of stuff from Starlark, and the Go code in that binary is going to figure out the rest of it. So I would very much recommend that pattern. It lets you do much more elaborate stuff. So just for an example of why you would want to do this, Go has build constraints. So in Go, you can say like this file is only for Linux. This one is only for AMD 64 and so on. And you can write these as comments in your Go file. And they can have like arbitrary Boolean conditions. And I mean, C++ has stuff like this too, right? You have like if def and so on. So you shouldn't pass files that are like ignored by constraints to the compiler. The compiler does not know anything about these constraints. You need to use like some other library to do this. And you're not going to be able to figure that out in Starlark. Starlark can't read the files. So you have to like call some other command to figure out what files to compile and then call the compiler. So what I'm suggesting is like just wrap all that logic into a single command and have that be the wrapper around the compiler and the linker and so on. So the code, let's see, the code. I totally switched over V3, or skipped over V3, the run files. If you want to see the code, please check out the repo. So in this one, we have our internal builder directory. So this has a Go tool binary rule. And this is basically identical to the Go binary rule that we wrote at the very beginning. So this is just uses a shell script, and it depends on the standard library. So this has a bunch of files. I don't want to make this too Go specific, but I'll look at the compile file to give you an example. So we pass in arguments. We pass in, here's the path to the standard library. This is just like a directory name. We pass in a list of archives. So these are those like package path equals file, the things that we got from the Go library info provider. So we're basically turning those providers into arguments. We have our package name and our output file. And so we run all of this Go code, and eventually we call Go to compile with like the translated set of arguments. So this lets us like lift all that complexity out of Starlark. It lets us be more hermetic and less dependent on bash or any system specifics. Just to show you how this is called. So here's Go tool binary. This is very similar to the one we wrote earlier. I actually didn't extract this into a separate function for the tool chain. This is just going to directly call context actions run. Still using our cheat code here, use default shell env. I will show you the modified Go compile. So we're going to do something a little bit different here. Before we were passing in arguments as just a list of strings. In this case, we're going to use an args object. So we call context actions args to construct one of these. And then we can call args.add to like add a flag to it, to add an argument. So this has a bunch of useful utilities. If you're like formatting command line flags, this comes up in particular when we're passing in our providers. So I give it a list of our dependencies. So these are all those dep info objects. And I say before each of these pass the arc flag. So it's going to say arc A, arc B, arc so on. And I also want to map each of one of these. So I have an object and I want a string. So this is calling format arc. This is just a local function here. Just call string format to put it in the right format for us. Let's see, can I go back? We can optionally add stuff, and then we add all our sources at the end. So remember, like sources is a list of files here, and we, again, need a list of strings. So args.add and args.addAll will actually translate the files to strings automatically for us. So it'll turn each of these into relative paths. So this is really convenient. There are a couple other bits of functionality that are useful here. If you have a very long command line, again, like Windows is going to come back to bite us again and again and again. Windows has a relatively short command line length limit. Like it's quite a bit shorter than Linux. And so it's frequently useful on Windows to spill arguments into a file and then tell the command to read the file. And so if you have written a program that can deal with files like that, you can also you can have args do that automatically for you. So I can look. You can look up the documentation on how to do that. You can tell it which file format you want to use. You can tell it whether you want to always do that or just like only when necessary. But it's very useful functionality. Last thing about args, if you want to add a depth set, let's say you have like a few 100,000 dependencies, like it's very large command line length, you can add a depth set. And if Bazel is not actually running that action, then that depth set doesn't get iterated. So Bazel doesn't spend the time expanding that file, that depth set, unless it actually wants to build the action. So a little optimization. We're calling run instead of run shell. So this is a little bit different. I would advise like always use run, not run shell whenever you can, whenever possible, for all of the bash reasons. Very similar, like you give it an executable. This is a file. You give it a list of arguments as before. You can set the environment variables, like pretty much the same. But you don't have to worry about like string interpolation or escaping or anything like that. All right, any questions? Yeah. We are still relying on the Go toolchain that is installed on the system. So in the next unit, we're going to start our journey to downloading that. I don't think we're going to get all the way through it in the next 30 minutes.
Maybe a silly question. Why are you adding the sources both to the inputs and to the args?
So the adding to the inputs doesn't do anything to the command line. So it just makes those files available when the action runs. So within the sandbox, the action can see them. But unless the action does something like find dot something something, it won't actually be able to see those. So we also have to add them to the command line. All right. Question?
So, you didn't touch on it here, but you mentioned that you had this approach where you put a function within the toolchain itself.
Mm-hmm.
Like that sounds great. Is there any sort of penalty, or would you say it would become very expensive to have functions within providers as well? Like how expensive is for how expensive is for Starlark or for Bazel to carry around like closures? Like is it expensive? Like is it because we have relatively few toolchains, so it's fine. But when you move that to providers, that suddenly becomes like large and complicated.
It used to be difficult to do that because there weren't any lambdas in Starlark, so you only had top-level functions, and there weren't very many cases where you would actually want to. So now that there are lambdas and inner functions, you can capture stuff. And so I'm not actually sure the answer to your question, whether it's possible or not, because
like,
it is possible. Okay.
I've always wondered, like, am I going to trash performance if I do it, so I just avoid it?
Yeah.
I'm just like, is it?
I don't think there's any performance penalty for it. The thing that I was worried about is if this ends up in a depth set or somewhere, it has to be hashable, and I don't think lambdas are hashable.
Like easy things like, oh, I want someone using my provider to be able to like call it as an object. And
Yeah.
And then since function may have a reference to something else in the provider that can do funny things like, oh, give you the list in a
Yeah.
particular format. Like, it's very handy, but it's also allowed the smooth
I don't think there's any significant performance penalty, but I mean, anything performance critical, like avoid Starlark, right? Like Starlark is not fast.
Yeah.
Unless someday they compile it to JVM bytecode and just run it. That'd be cool. But no, not now. Oh, persist. Okay, let's see. Got to read my own slides. Okay, so again, my recommendation, like move as much complexity out into actions as possible into the execution phase. This is the best way to do anything heavy, anything complicated, anything slow should be there. I'm gonna pitch remote execution a little bit. So in general, like you want to parallelize your work as much as possible. And ideally, like you can push that out onto other machines. And so if you write your rules in a way where actions are fully isolated and they can run on any machine, like perhaps with some system constraints, that is going to work very well. So there's kind of an art to figuring out how big the rules should be. Like Go has like Go and CGO. So if you are combining C++ and Go code, you can write your C++ code in comments, and you can write it in C or C++ files alongside your Go code. And there's some magic that makes that work. So Go will actually like run it through a compiler, figure out what the types of the C++ code are. It'll build all the C++, and then like recombine it at the end. And so there are like a bunch of steps to that. And the question that I had at some point in Rules Go was like, should this be one action, or should it be lots of little actions? And like, it's kind of hard to make that decision. I ended up making it one action, but it doesn't work well for libraries where there are a bunch of C++ files that could be compiled in parallel. Like it simplifies the graph. So I'm going to give some contradictory advice here and say like leave it up to your own judgment. Avoid a lot of tiny actions that have the same input files, and you're going to be setting up you're going to be paying the same overhead for every one of these, and they're not really going to be running long enough for the parallelism to make a difference. On the other hand, if you have like some big action, like the CGO thing, where like you could split it out into like lots of pieces that could be parallelized and would be much faster, you can do that too. So you can go in one direction or the other and kind of play with it and see what works. The last thing I'll say, like avoid shell scripts. Again, like repeating message, like prime directive, subprime directive, like don't do anything in shell. Like it doesn't work. It's different on Mac OS, like it's different on Linux. Like different things are installed, like just, it's not hermetic. Like it'll work locally, it doesn't work with remote, vice versa, who knows?
What's a good language to write the wrapper in?
Oh, Go, of course. No. Probably like whatever pulls in the fewest dependencies. That's my actual answer. So if you're writing like rules Java, write it in Java. If it's Go, write it in Go. If it's like rules JS, like do something with Node. Like if you're pulling in like an extra tool chain and like building a bunch of extra stuff to make that happen, like a lot of overhead. Yeah.
Although I guess since Bazel always pulls in Java and Python, those are two obvious defaults.
Yeah, I guess you have those at your disposal.
I would say if you are using C, don't write in C because it will be painful.
Yeah, perhaps.
Yeah. True.
I'm gonna tell you about another bit of functionality. So there's something in Bazel called persistent worker. And so the idea with a persistent worker, this is another one of those strategies. So normally, like one action is going to be like one actual like command Bazel runs. So it's actually going to do, one action is like one fork and exec and so on. With persistent workers, you actually get a process that is kind of a daemon that runs alongside Bazel. So Bazel will tell it like, hey, I want you to run this action, and then the worker will do it and then come back. And then Bazel will say like, I want you to run this other action and so on. And so I'm not gonna go into detail in the slides or anything, but check the documentation. These are not super hard to write. You need to be able to like read and write JSON on a pipe. That's how Bazel communicates with these. What? Protobuf. I think there's a JSON mode. There are like you can switch which one you want. But these save like a ton of overhead. So the the Java rules use these in particular, and so it doesn't have to like go and reparse like every jar file ever, like for the standard library. So I think it makes like something like 30-40% performance improvement like per action. Like it's much bigger difference than you would think.
You got an example in your repo?
I don't.
I didn't mention it, but the Bazel Mod Migration Bootcamp repo does have a tiny toy example of a persistent worker.
So check out the Bazel Mod Migration Bootcamp. Yeah, I think Go doesn't lend itself to that all that well because you would have to like directly communicate with the compiler code. So you would have to like take all the compiler internal packages and like link them into your binary. So I mean, how hard it is depends on the language. So use your judgment, but know that this is a really powerful optimization. This also works with remote execution. So there are remote persistent workers too. Passing information to action. So you need to write all this on the command line. Starlark has JSON.encode, and there's also JSON.decode, you can imagine. So if you want to shove a bunch of structured stuff into JSON and then decode it in your action, that works. If you want to write a file, just like as an action, you can do context actions write. I talked about args pretty thoroughly, so I won't talk more about that.
There's a proto encode and decode too, right?
I think there might be. Yeah, I've never actually used it.
Yeah.
Yeah. Profiling. If you are trying to measure like how long things take, Bazel has a bunch of built-in profiling mechanisms. So you can run any build with -- profile and write that out to a gzip file. You can use Bazel analyze profile later to read it back. And this includes like information from like every file system operation. So you can say like, oh, I'm doing a ton of globs over here, or I'm doing a ton of extra access here. I heard Fabian recommend this last week. I think there's an optimization in Bazel 9. He recommended using directories whenever possible instead of glob. So glob is surprisingly slow. Like Bazel needs to like, if you depend on something that's a glob, Bazel needs to actually like evaluate that glob. It needs to walk the directory tree and figure out what all those files are. Whether or not it's, so in order to build the target, the action graph. If you just depend on a directory directly, it doesn't need to walk that. It just says like, I depend on that directory. And it can like, I'm getting this wrong a little bit. I haven't really thought this out ahead of time. You look like you have a question.
Yeah, I was just wondering, would that be a directory that's the result of another action? Because wouldn't it have to walk?
It could be, but it could also be a source directory.
But still, it would have to walk a source directory, right, to make sure that it hasn't changed.
I think this is actually an optimization at the load time rather than the analysis time. I might have this a bit wrong. Anyway, something to check out. If your globs are a little bit more expensive, see if you can use that.
Do you remember where Fabian mentioned this?
I think it was in the rules SIG, the special interest group meeting last week. That doesn't really help you.
So it wasn't in the Bazel Slack.
No. You might have also mentioned it in Slack. One other, so you have a profile. You can view this with Perfetto. So Perfetto is like Google's tool for, I think, analyzing Android profiles, but it's a general purpose like profiling mechanism. I think this is actually built into Chrome now too. It's like Chrome profiling or Chrome Perfetto, something like that. Or there's a separate tool. One other resource, like EngFlow has an open source analyzer. So you can do analyzer.engflow.com, upload your profile. It gives you some recommendations, like try enabling this flag, that type of thing. It's an open source tool. You can download the command line version of it if you don't want to send us all your data. Yeah. Did you have a question?
No, we use it, it's very good.
Oh, glad to hear that. All right. We have 15 minutes left. What would you like to hear about? Probably we can get through one of these topics.
Can you talk about the alternative using the shell?
Oh, the shell equals true. Yes, I promise to get back to that. I will give you a quick overview of these last three. So use default shell env is going to leak in from the user's environment, the path variable and so on. That is going to completely break when you have remote execution because like maybe my Go binary is installed in a different place than yours. So we want to use tool chains for that. So these last three modules, and I apologize, we're not going to have time to get through all of these. All of this, by the way, is in the series of blog posts, and it's all like in detail in the different branches. In the first version of this, we write a repository rule. And this is going to download the Go toolchain and extract it and set up a build file. So this is... We know repository rules, they're HTTP archive, get repository, and so on. You can write your own. It's not that hard to do. I would generally recommend, not using repository rules. No, Mike has a better explanation of this. So use Bazel dep if you have I'm just gonna like copy what you said in your slides. I know.
This is like a sync-like dependency.
You had a more eloquent explanation, I think.
I did?
So in Mike's slides, he said if your dependency is in the Bazel central registry in your module.bazel file.
Even if it's private registry.
Right. If it's a Bazel module, then depend on it with Bazel dep. If it is a simple archive, like you can use HTTP archive, get repository, and so on, use that. Use a repository rule. And if use repo rule. And if you have something more complicated where you need to gather information across your module graph, then you'll use a module extension.
Or if you need to share that repo with other modules.
Right. And so the reason I bring this up, if you're writing such a thing, you may need to write a module extension. And what we need to do here is we'll say like, this module depends on Go 125. This module depends on Go 121. We want to figure out which version we should actually fetch. And so we need to collect information across our module graph, which means we need a module extension. But before we can write a module extension, we need the repository rule to actually be able to fetch that thing and set up its build file. And so that's why I start out with repository rules. It may not be the tool that the users use directly, but it is the thing that you have to understand first before module extensions. So yes, repository rules, you can fetch it. I will show you the code quickly. I think it's v5. So this one is relatively simple. So it's go download impl. You declare it a lot like a rule, except you use the repository rule constructor instead. It has the implementation function and it has a list of attributes. And so this one, we have our URLs, our SHA-256. This is like basically HTTP archive, except we also need to add in a build file for it. And so we have some parameters that are, we have a template file that we're going to expand into that build file, and we have this stuff that is going to end up in that template. And so to actually do that, we call context download and extract. And here's where that report progress comes in. Because like these take a long time to run. And it actually runs while the Starlet code is being evaluated. And so you can actually tell the user like, hey, I'm downloading this, or hey, I'm extracting it. So once we have that, we just call context.template. That writes out the file directly. So it expands the template and writes the file. And speeding on through, that's it for repository rules. So, these are allowed to do a lot more than regular rules. So they can do their I/O, they can run commands directly, use the power responsibly. And again, don't do stuff in Starlark. The problem is that these can't rely on any executable that you've already built. Like repository rules run first and then the rest of the build. They run as part of the load phase. And so it's actually very hard to extract all the complexity out of the repository rule and into the execution phase. You can't do it. So you can pre-build some binaries, maybe. I mean, it kind of breaks the purity of Bazel, but it's an option. or you can have some complicated commands to build the binary that is like more complicated code. So yeah, so I don't know if you've used Gazelle or Go repository. So Gazelle has the Go deps module extension. So this fetches a bunch of Go code and it generates the build files for you with Gazelle. And in order to actually run Gazelle, it builds Gazelle inside a repository rule. So it's super ugly and it's actually kind of slow, but it works.
Advertising, like now there is a WebAssembly extension for repository rules. So you can run the complicated code as whatever language is used WebAssembly. It is very slow. What is it?
It's an option.
Yeah.
Tool chains. So tool chains, the key insight with tool chains is that they're dependency injection. So Mike talked about this before in his section, but I'll repeat it now. When a rule depends on a tool chain, it's just depending on a symbol. So you say like, I need the Go tool chain, I need the C++ tool chain. The user registers all the different tool chain implementations that they want. Like here's one for Linux, here's one for macOS, here's one for Windows, and so on. And Bazel will automatically pick which tool chain you're going to get based on the constraints. So this one is compatible with such and such. So when the rule actually runs, you get access to the tool chain. I have to define a bunch of nouns for this. So a platform is description of like what I'm targeting. So I'm going to have a target platform and a execution platform and a host platform. So the target is like the final binary is going to run here. Bazel doesn't actually run code there. Execution platform is where Bazel actually runs actions. You can have multiple of these. So by default, it's going to be the same as your host platform where Bazel actually runs itself. But if you're in remote execution, you might have several different execution platforms. So you can be like, building on Windows, Linux, macOS all at the same time. To describe a platform, you have constraint settings and constraint values. And so a setting is a category of values, and a value is just a fact. Like this is Linux, this is x86, and so on. The tool chain is essentially just a target. Like tool chain, there's a built-in tool chain rule in Bazel, and it is just a collection of these constraints. So it says like this is compatible with Linux, x86, so on. You have a tool chain type. So this is the symbol that the rule depends on. And finally, you have an implementation. A lot of nouns, I'm sorry. Like, I hope it's somewhat clear. Code. Switch to V5. No, we're already on V5. Great, excellent. So we have our toolchain type. I put this in the root build file. Again, this is part of the public interface. This needs to be a symbol that the rules can reference. It needs to be public. It doesn't carry any information other than the name. So we just say like it's toolchain type, and you would reference this as rules go simple toolchain type. That's it. To actually communicate something interesting, we're going to define a new provider. So there's this Go toolchain info provider. I put here the methods, like the compile and link method here. And there's also going to be a build test. So I skipped over like actually running tests, but to make a test rule, you basically just have to say like test equals true, and it has to produce an executable. That's pretty much it. And Bazel will take whatever executable the rule produces and run that. Just to make sure I mention that. All right. A repo rule. I didn't show you the build file template before, but here it is. So this is the one we actually produce. Here's our Go standard lib. Here's our Go tool binary. And we're actually going to declare the tool chain right here. This is a bad place to declare it. I'll get in. I have like 5 minutes left, but I'll at least tell you why it's bad in a minute. we build our, let's see, we register our toolchain. This is the toolchain implementation. This is a rule that returns that toolchain impl provider. It takes in like all the stuff that we would want, the standard library, the builder binary, and some binaries that are actually pre-compiled, not the whole thing, but at least the compiler is there. And then we have this Bazel built-in toolchain thing. So this, again, carries very little information on its own. It's just a binding. So it has a list of target constraints and executable constraints and the toolchain implementation and that symbol. To actually depend on this toolchain, in our rules, this is our, let's find our Go binary. Yeah, Go binary. We have this toolchains thing at the end. So we just give it a list of the toolchain type labels. And in order to pull that out, like to actually use it in the rules implementation, we say context toolchains and give it that same symbol. So this is like a little bit like the providers. We give it like, overloaded subscript thing. We get that provider back. So that Go toolchain info thing is here. And we call that method that we stored on it, the compile method and the link method. I have 3 minutes left. The only thing I'm going to say here additionally is toolchain resolution debug is going to be your friend. It's like, these are deterministic in how they're selected, but it's kind of hard to see like, oh, why didn't my toolchain get selected? Or why did it get selected? Like, I don't know. Toolchain resolution debug, just you give it a regular expression, it matches like whatever the toolchain type is, but just give it dot. Like make it spew everything and then just, like dump that to a file, analyze it, like it'll make more sense. So again, I promised to explain like why I was doing that way. I'm at least going to say the problems. I showed you the way I was loading toolchains, like I was declaring the toolchain in the same repository rule as where it was actually built, which means that when you say register toolchains to Bazel, you have to like tell it all the toolchains that you're going to have. Bazel needs to go and read that build file that has the toolchains in it, so it knows what the constraints are. And then it can evaluate the constraints and pick which one it's going to use. But the problem is, if that's in a repository rule, it actually needs to evaluate the repository rule. And if that repository rule also downloads 100 megabytes of code, that's slow. And if you have like 30 of them to support like all the different platforms that you might want, then it's downloading 3 gigabytes of code. Which is why I say like don't do it the way that it's in all the units up until now. So yeah, if you call register toolchains, that forces the repository evaluation. You can also end up with like multiple repositories, like all redundantly calling for the same toolchains, like maybe with different names, and everyone has to list like all the things they depend on. So what I'm suggesting for this is a module extension. So the concept with the module extension is you have like Bazel's module graph, and it can depend on like other module graphs that are not just like Bazel central registry modules. So a module extension lets Bazel plug into like the Go module graph and the Rust module graph and so on. But what we're going to use it for here is toolchains. So we can say like anyone can use a module extension to fetch a Go toolchain. They can say like I need Go 125 or I need Go 121 or so on. We'll pick the highest version for that, and then we'll just declare repository rules for that version. So I'm going to skip right to the code and show you how that works. I say skip like I don't have 1 minute left.
Well, you're the last one.
I know. But you guys want to eat, right? I mean, you're probably tired of hearing me
We're
talk.
hungry for knowledge, Jay.
This is like the last thing I'm going to show you. So the module extension, you declare it with this constructor. You give it your implementation. You give it your tag classes. These are like input values for it. And this basically has 3 steps in it. So you select a version. You can iterate over your module graph and figure out whatever the highest version is, and we'll pick that one. And then this is actually going to go download a file. So this file is a JSON file. It has the list of all of the Go archives, the tool chains, and their SHA-256 sums. So we'll download that, we'll decode it, and we'll loop over it to find the version we want. And then for each platform, we're going to instantiate our Go download repository rule. In this version, we no longer have our toolchain in here. We're going to do one more thing, which is we're going to call this Go toolchains repository rule. And this is an extremely small repository rule. It just has one build file that has all the toolchains in it that we generate right now. And so Bazel always has to evaluate this one, but it's super cheap. And then once the toolchain selection is done, then it can go actually fetch that toolchain and build it, and not select like, you know, Windows, ARM, whatever. So Mike coined the name for this pattern, the toolchainization pattern. So like,
I thought I was reusing an existing name for some reason.
I think you invented the name for it. I first saw this done in Rules Go. I think Fabian maybe invented the pattern for it.
Where I got it from.
Yeah. I thought it was really clever. Highly recommend this. Yeah. I have a bunch of other stuff I could get into, but I'm actually going to leave it there. I'm very happy to stay here and answer questions, but I'm not going to hold any of you here. So, yeah.